actually early because that's when the transition in the interstitial was. So during this next segment, we are going to be premiering uh, the newest episode, latest episode, I guess both words work, of Escape Velocity Space News. And I just have to say, I paused it when I brought it up on screen, and I have never had a pause that looked that good before, and I just need to point that out. I can't believe that's me. And Allie, you made me look good and look like I'm ready to murder someone. I don't know how you did both at once. It is quite excellent. All right. So, while this is playing, thank you, Astrowise. Thank you. Um, and it's good to see you here, Astrowise. It's good to see you here. Um, so I'm gonna start this playing, and uh, I will be back before it ends, and then we will take questions. I don't know if Allie and Eric are going to be able to join. Allie is desperately preparing for her first foray into Minecraft, which luckily is going to include uh, several of our community experts and creative mode, so she doesn't need to worry about death. So don't go anywhere. Please enjoy our latest episode. This is a labor of love for all three of us. Oh, wait. Someone's trying to join the Zoom. Let me see if it is Allie or Eric. I lost the window. There's the window. I now have two of me. Let's stop that. It is Allie. Hello.
I'm sorry, did I just mess everything?
No. I was getting ready to introduce the uh, episode. I had said, I don't know how you managed to, like, I stopped the video and you somehow made it so I look both like amazing and also ready to murder someone in the most spectacular of ways. This is currently up on stream if you want to take a look at it. I'm
I'm looking. It's amazing. And I like that's all you. Pamela makes the best facial expressions and is like a delight to edit video for.
especially when I make mistakes. I'm like,
Hmm.
because sometimes it's like mispronounced words taste bad. So noisy. Yes, you forgot that, but don't worry. I did post the link for you. So the link was there, and I really appreciate you putting it again because I only remembered to put it once. So you did the right thing. Um, all right. So I was just
I'm
gonna let this.
excited to play with Radio Joe. Okay, yeah. Let's
I was just gonna let it run and then disappear and then come back in like 25 minutes.
okay, and then we can talk to y'all about the episode.
Yeah. So I'm just
Maybe
gonna.
have a little Q&A if people are game.
Yeah, I'm just gonna slide this window down and over
Okay.
onto another screen. Make myself disappear once I find where that is.
Yep.
All right, I'm putting me away and starting to hit play. Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. This episode is coming to you late because sometimes we're guilty of just wanting to see how the story ends. 2 weeks
Is
ago,
our
I was planning to
audio
drive
piped
to the
in
Space
or are
Coast to
we
try and watch Hera
okay?
launch on October 7th and Clipper launch on October 10th. Instead, I watched from home as a
What's
hurricane
happening?
named Milton tore across Florida and spawned more than
I can't
120
hear you.
tornadoes. Allie, our producer, and I talked that afternoon as I watched Max Velocity on YouTube. She and I decided to hold off recording until we on YouTube. She and I decided to hold off recording until we knew if KSC would come out okay. And when launch was announced for Clipper for Monday, October 14th, we waited to see if Clipper would join Hera in having a successful launch. So here we are, a week late, and two more spacecraft richer. And in our closer look, I'm going to take you on a tour of what we can dream of learning in the coming years as these missions make their way through our solar system to their targets in the asteroid belt and around Jupiter. We're also going to look at black holes and the confusion that is the Starship program, and IFT-5's launch and spicy landing. All this and more is coming to you right here, right now on EVSN, a product of CosmoQuest X and supported through our Patreon. Every once in a while, a story comes along that just makes me smile and also forces me to fix some of the misinformation living in my brain. Consider the microscopic black hole. In my brain, these diminutive creations of the early universe should all have evaporated away thanks to Hawking radiation. It turns out, however, I was thinking too small. While the tiniest of possible primordial black holes, those measuring hundreds of million tons and smaller, will indeed have evaporated away. Those that are a bit bigger, say 1 billion metric tons or larger, should all still be hanging out in spaces smaller than your typical carbon atom. To be clear, in the earliest years of our universe, tiny black holes may have formed, and some of those sub-atom-sized beasts could and should still be out there. And a group of researchers published a paper in Physics Review D with first author Tung Tran, and in this paper they discuss how some of these tiny monsters just might be randomly making their way through our solar system, where they have the potential to create tiny amounts of havoc by moving things around with their not so tiny gravity. In an extreme case, where all dark matter in our universe is explained using asteroid mass black holes, there would always be a black hole or two passing through our solar system. Most passages would cause no noticeable effects, but this team estimates that about once a decade, an observable orbital change should occur. While we haven't yet seen asteroids or other objects make an unexplained jig in their orbits, this team of researchers believe that the changes we're looking for should be observable. This will be especially true in the near future as the Rubin Observatory begins its survey. And if we don't see any bobbing and weaving worlds, that also tells us asteroid-massed, atom-sized black holes aren't the only source of the missing dark matter mass we're looking for. And in my scientific opinion, dark matter is most likely going to turn out to be a mixture of different things. And microscopic monster black holes could be in that mix. The definition of a black hole allows for these objects to have a wide range of sizes. Basically, every mass requires some amount of velocity to escape its surface. Our planet has an escape velocity of 11.2 kilometers per second. The asteroid Bennu had a minimum escape velocity of 17 centimeters per second. But those escape velocities are due to the sizes of each object as well as the mass. As you compress a world smaller and smaller, you have to go faster and faster to escape its gravity at the surface. If we took all of Earth's mass and compressed it down to less than 2 centimeters. The escape velocity would rise all the way up to, and then past as you went smaller, the speed of light. And since nothing with mass can go the speed of light, let alone faster than light, a less than 2 centimeter sized planet Earth would be a black hole. If you compressed the moon down to zero point 0.2 millimeters, it would be a black hole. If you took a person and made them tens of thousands of times smaller than our estimated size of an electron, they'd be a person black hole. Ant-Man, at his smallest, totally a black hole. Anything smashed until it has an escape velocity equal to or greater than the speed of light is a black hole, including Ant-Man. But black holes don't have to be small, and massive black holes lurk in the hearts of many galaxies. With sizes smaller than a solar system, these beasts can have masses billions of times bigger than the mass of the sun. These supermassive black holes can form massive disks of rapidly orbiting charged material, so-called accretion disks. And these disks can generate powerful magnetic fields and, like railguns, fire particles out at high velocities. And when these jets fire for long enough periods of time, they can grow in length to millions of light years. For comparison, galaxies like ours or Andromeda are only a few 100,000 light years across. These massive particle fountains influence the formation of structures, and according to a new paper, may even influence the evolution of regions of our universe. The largest set of jets found so far are 23 million light years in length and extend away from a galaxy that shined its light toward us when the universe was only 4.4 to 6.3 billion years old. It was discovered by citizen scientists examining data from LOFAR, an array of radio telescopes in the Netherlands. To form the supermassive black hole in the center of the originating galaxy would need to be actively feeding on material in an accretion disk for millions of years. It is unknown how many objects like this may be out there. What we do know is they were more common in the earlier universe, when there was more material available to feed black holes. Over the eons, black holes have both consumed material, and the bright light from accretion disks has pushed outwards, triggering mass to form stars and blasting it out of reach of the black hole's messy eating. Today, not so much activity is out there, waiting to mess up galaxies. In our next segment, we're going to switch from tiny objects with huge masses to small objects with small masses. Stay tuned for a look at Hera, Clipper, and the worlds they'll explore. It is impossible to overstate how much more we can learn about other worlds when we visit them. Even from Earth's orbit, where the atmosphere doesn't interfere with picture quality, we just can't see the same details. I'm going to put some numbers on this. When the Europa Clipper mission reaches Juno in 2030, it will begin a series of flybys that bring it as close as 25 kilometers from Europa's surface. From a distance of 100 kilometers, a 1 kilometer feature on Europa's surface will be half a degree across and appear as wide as the moon does from Earth. From Earth, that 1 kilometer feature on Europa would appear 400 million times smaller and is beyond the physical limits of even our largest optical and infrared telescopes. Since our last episode, NASA and ESA have launched 2 amazing missions on million-mile journeys to seize some of the smaller objects in our solar system. On October 7th, with Hurricane Milton spinning up off the west coast of Florida, the European Space Agency got in one final launch ahead of the weather. The Hera mission launched on a Falcon 9 and headed straight away from Earth. This mission is a follow-up to NASA's DART mission and will let us see just what happened to the small asteroid moon Dimorphos after it was purposefully hit by the DART mission. DART was designed to test our ability to change asteroids' orbits as we prepare to one day potentially protect our Earth from an incoming space rock. While we can see that Dimorphos's orbit around the larger Didymos asteroid has indeed changed, we don't see what literal impact the DART mission had on this binary asteroid system. With Hera, we will finally get to see if a crater formed, if changes are visible on the main asteroid Didymos, and answer myriad other questions about the cloud of debris that we did see reflecting light here from Earth. The journey to the asteroid belt is a long one. In March 2025, Hera will fly past Mars and train some of its scientific instruments on Mars' moon Deimos. In addition to allowing new science to be done while testing Hera's instruments, this side quest will also provide Hera with a velocity boost as it slingshots around the red planet. If all goes well, Hera will catch up to Didymos and Dimorphos in October 2026, and in 2027, the mission will go all in on imaging and exploring Dimorphos with the goal of making it one of the most studied objects in our solar system. NASA's Europa Clipper has been a long time in the making, and it finally got to launch on October 14th, 2024. The 2011 Planetary Science Decadal Survey set out exploration of Jupiter's large icy moon as one of its highest priorities. Europa, with its ice-covered oceans, is the most likely place in our solar system to have present-day life. And I think it is safe to say, all of us in the space science community want to know if life exists beyond planet Earth. NASA took the Decadal Survey's recommendations to heart and in 2011 commissioned studies to explore what it would take to do a flyby mission, an orbiter or a lander. Ultimately, we all had to acknowledge that we don't have the capacity to sufficiently sterilize a lander and prevent Earth microbes from contaminating Europa. Instead, the safest way to study Europa and avoid potential contamination would be a mission capable of making multiple flybys of Europa as it orbited Jupiter. In 2014, NASA began planning the Europa Multiple Flyby Mission, which would later become Europa Clipper, which is much easier to say. Europa Clipper was planned to launch on the still under development SLS rocket on a direct-to-Jupiter trajectory that would see Clipper arriving at Jupiter in less than 3 years. Unfortunately, delays in the SLS program and the needs of the Artemis program combined to make this kind of a launch impossible. In 2021, the mission looked for a commercial alternative and landed on the less powerful Falcon Heavy. With the help of the gravitational assists of Earth and Mars, Clipper will be able to reach the Jupiter system in 5.5 years. Currently, Europa Clipper is slated to arrive at Jupiter in June 2030. From commissioning designs in 2011 to arriving in 2030 to finally making a flyby of Europa in 2031, this is a generation-defining mission. And NASA has made sure Clipper will be worth the wait. Powered by the largest solar panels ever placed on a space probe, Clipper is carrying 9 scientific instruments that are designed to do everything from map Europa's ice with ground-penetrating radar to measuring the composition of any captured materials. Thanks to the onboard suite of cameras, there is the potential for Clipper to see hot places on Europa's surface, detect geyser eruptions as they take place, and to maybe even direct the mission to fly through the plumes of material from geysers and verify if the stuff needed for life is present in Europa's waters. To be very clear, Clipper isn't carrying the kinds of instruments that are needed to detect life. I can't look for fragments of RNA or DNA with Clipper data. It doesn't have the kinds of microscopes that could look for cells if it happened to catch a large enough sample. Clipper is not a life detection machine. Clipper is instead looking for the stuff needed for life, the organic molecules that are the basis of bodies and food for life on Earth. If we can find the requirements for life, then Clipper's maps of Europa's surface and structure will allow us to develop future missions that should be able to directly look for life. We have so much planning to do before we can look for life, and that planning is taking place here on Earth. Researchers are developing the autonomous ocean explorers and testing different technologies both in the high-pressure depths of Earth's oceans and in the dark and barely accessible sinkholes and subsurface waters of South America. We still need to sort how we cut through the ice, get a signal from beneath the ice, and sterilize a spacecraft. But all of that will come with time and with money. But for now, we wait. Europa Clipper has successfully deployed its longer than a basketball court solar panels and is communicating with NASA's Deep Space Network. As we hear more from the mission, we'll keep you updated. After the break, we'll be back with this week's Tales from the Launch Pad. And somehow, things got stranger than fiction this week. Stay tuned. Next up is this week's Tales from the Launch Pad. Eric isn't currently available to record, but he has sent in one heck of a script that includes news of SpaceX's Clean Water Act defying launch of Starship and so much more. I have to say that launch was the weirdest combination of amazing visuals, spicy, melty engines, and failure to follow federal regulations. I am deeply confused by the entire situation, and we have reached out to NASA for comment. For now, though, let's look at everything that flew, starting with a Chinese launch. Smart Dragon 3 is a new all-solid launch vehicle. This was its fourth launch. The 8 small sats came from various Chinese companies. On September 24th, China launched the fourth Kinetica 1 rocket from the Huaqian spaceport. Let's watch the launch. The launch carried the first 2 AirSat satellites for a communications satellite, the first radar satellite in the prolific Jilin-1 constellation, and another satellite for the Yanyao weather constellation. On September 25th, JAXA launched the second-to-last H-2A rocket from the Tanegashima spaceport in Japan. Let's watch the launch. IGS is the Japanese military's intelligence satellite constellation. It consists of radar and optical satellites. H-2A has launched 49 times so far, with 1 failure. The last launch will happen this year. On September 28th, China launched the Shenzhen 19 satellite on a Long March 2D. It was described as China's first reusable and recoverable test satellite. Let's watch the launch. The capsule successfully returned to Earth on October 11th after performing biology experiments, technology demos, and other experiments in low Earth orbit. On October 4th, ULA launched the CERT-2 mission on a Vulcan Centaur rocket from Slick 41 at the Cape. The second Vulcan launch was supposed to have Sierra Nevada's Dream Chaser as payload, but it was not ready, and ULA needed to get a second launch done this year to be certified for U.S. military payloads, so they came up with a Plan B. Instead of the space plane, the primary mission would be demonstrating advanced capabilities of the Centaur 5 upper stage. Inside the fairing was a 1.5-ton aluminum test mass and many technology demonstrations ULA wanted for future enhancements of the stage. Eventually, they want to have the stage powered by hydrogen and oxygen boil off via a small internal combustion engine, and that same boil off gas for maneuvering thrusters, as this saves massive amounts of weight in batteries and hydrazine thrusters and allows the stage to remain useful for months, not hours. The Centaur for this mission would end up in solar orbit after 2 burns. The launch wasn't perfect. About 50 seconds in, one of the nozzles of the SRBs blew off, but fortunately, the fracture pointed away from the first stage tank. The rocket adapted with its engine gimbal, and the mission was completed with 0 issues. They were also fortunate the mission had a light payload, even though it was heading to deep space. ULA will probably have a hard talk about their SRB supplier, but probably not need a 3rd certification flight. On October 7th, SpaceX launched the Hera mission to Didymus. Let's watch the launch.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engines full power, and liftoff. Go Hera, go Falcon, go SpaceX.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
SpaceX received special permission from the FAA to conduct the Hera flight while Falcon 9 was grounded and under multiple launch mishap investigations, because it was an important mission that just could not be delayed. Fortunately, the launch was successful this time. Hera is a mission to Didymus to explore the impact that NASA's DART spacecraft, launched on Falcon 9 as well, had on the Didymus system. Hera will conduct a flyby of Mars and arrive at Didymus in 2026. Once there, it will deploy 2 CubeSats. On October 10th, China launched the WHG-3 satellite from the Kai-Chang spaceport. Let's watch the launch. WHG-3 is the 3rd high-orbit Internet satellite launched for the new constellation operating in geostationary orbit. No pictures of the satellite were posted. It will be used by the Chinese government. One launch worth talking about in more detail is Crew 9. This mission had more than the usual amount of drama for a routine crew rotation mission. Let's watch the launch, then talk more about it.
5, 4, 3, 2, 1. Ignition, engine full power, and liftoff. Crew 9, go SpaceX, go Falcon, go NASA.
Liftoff of Crew 9 now soaring to the International Space Station.
Stage 1 Alpha. Stage 1 propulsion is nominal.
Copy, 1 Alpha.
Those 9 Merlin engines now providing 1.7 million pounds of thrust, propelling Falcon 9 and Crew 9 and continuing to get good calls from teams here on the ground.
Of course, these incredible views mean we are just a little bit past 30 minutes or 30 seconds into our 9th rotational crew mission.
Power range telemetry nominal.
Onboard Dragon.
The original plan was to launch 4 crew members as normal, but that plan was changed mid-August 2024 to only have 2 crew members launch with the spacecraft, so Barry Wilmore and Sunita Williams from the Starliner mission could return to Earth after NASA chose, for better or worse, to return Starliner without crew due to concerns with its thrusters. Nick Hoig of NASA and Alexander Gorbunov of Roscosmos would ride up, with Hoig acting as commander and Gorbunov as mission pilot. Starliner, of course, returned just fine, but it was too late to change the Crew 9 plans. Another new thing that Crew 9 required was launching from Slick 40, because 39A would be tied up with Europa Clipper and Polaris Dawn. SpaceX was already working on configuring 40 for Crew Dragon as a backup to 39A for when Starship inevitably blows it up, and just accelerated plans to finish the work. No, we're not sarcastic around here. The launch on September 28th was just fine. On low Earth orbit missions like ISS launches and Starlink missions, the second stage has the propellant margins to deorbit itself completely, unlike missions to geotransfer orbit that leave the stage in orbit to decay a few months later. On Crew 9, the second stage deorbited, but burned too long and fell short of the cleared debris impact zone in the Pacific Ocean. The FAA grounded Falcon 9 for a public safety investigation, closing it on October 11th, the second longest grounding of Falcon 9. On October 13th, SpaceX launched again, this time the 5th integrated flight test of the Starship vehicle. Let's watch the launch.
On the left hand, ignited. We're now down to 3 Raptor engines. We can see those chopsticks now in here.
IFT-5 was supposed to launch no earlier than November, but after a coordinated pressure campaign on the FAA by fans and Elon Musk, SpaceX got their launch license on October 11th. However, the FAA worded the license to wash their hands free of responsibility for the inevitable environmental violation, making it solely SpaceX's fault for continuing to operate a launch pad that breaks state and federal law. The Texas Commission on Environmental Quality has not given SpaceX the temporary permit they need to have a veneer of authorization, never mind the full individual MPDES permit, which will take a year. SpaceX was given an agreed order to cure their previous half-dozen-plus Clean Water Act violations the TCEQ and EPA had cited them for, but it was not yet signed by the Commission, which can only happen at a full meeting of the Commission. As of this writing, discussion of the AO was not on the future meeting agendas, currently posted through early November. So use of the Launchpad deluge system for IFT-5 would and did result in illegal discharge of processed wastewater into the waters of the United States. SpaceX's stated goals for this launch were to have the first stage return to the launch site and be caught by the launch tower. They promised extensive work had been done to fix the heat shield burn-through and booster engine section fire observed on the previous flight. Early in the morning on the 13th of October, the rocket lifted off from Boca Chica pad, industrial wastewater spewing outside of the site boundary, just like every other launch. About 2.5 minutes into the flight, the first stage separated and began its first return to launch site burn. To many people's surprise, the booster catch worked. Though the booster was actively on fire, pieces were falling off, and most of the engines on the outer ring were mangled, so this booster won't fly again. The ship made it through reentry with the same heat shield burned through as the previous flight and exploded when it hit the ocean. Overall, SpaceX made no progress towards the human launch system milestone for NASA, what this vehicle is actually being paid to do, instead of being a Starlink truck, as often advertised. And the mission experienced the same issues as the last flight. But the stands will have enough excitement to go on another harassment campaign of the FAA and its career bureaucrats. According to the original schedule for the Human Launch System contract, right about now, fiscal year 2025, SpaceX would be beginning its months-long 16-tanker, 1 depot, and 1 HLS lander launch campaign after doing a similar campaign for an uncrewed landing demonstration last year. Artemis 3 will be happening as scheduled. It's up to NASA and SpaceX to now come up with some alternate mission that still meets the goals if SpaceX can't land HLS on the moon as contracted. We could very easily dedicate a weekly segment to what laws, contracts, promises, and other things has SpaceX broken this week. We're not going to do that here. We are, however, going to report on what we're seeing and how it is going to affect the Artemis program, the environment, and more. You'll be able to catch these updates as short videos on the CosmoQuest Instagram, Facebook, and YouTube. I will also be writing about this over on my Substack. We want to see SpaceX and all the other commercial launch providers succeed. We want to see SLS finish up what we've already paid for it to do. We also want to see all the companies follow U.S. law, abide by the Clean Water Act, and not harass career bureaucrats with death threats. Anyways, we keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the United States has had 102 launches. China has had 47 launches. New Zealand has had 10 launches. Kazakhstan has had 6 launches. Japan and Russia each have had 5 launches. India and Iran have each had 3 launches. French Guiana has had 2 launches, and North Korea has had 1 launch. This makes the total number of launches so far this year 184. Finally, there are 10 toilets in space. Of those 184 launches, there have been 4 failures, reminding us space is hard. Before we go, I just want to say the sky has suddenly gotten super active with fleeting and beautiful things. On October 10, we had another amazing aurora show. And a couple of days later, Comet C 2023 A3 moved into the evening sky, where it has been visible even from places as bright as the Hollywood Hills. This image, by the way, you can see it on our website if you're listening to the podcast. It was taken by David Joseph Wesley looking straight out over the LA basin. And in this iPhone picture, you can see the comet. If you want to know about events like these, well, we let our followers over on Patreon know what we know when we know it. And you can follow along for free and get all the latest information, share your own stories, and just be part of our community. I hope to see you over there at patreon.com/CosmoQuestX. And that's it for now. Good night, everyone. And remember to go out and look up. Oh, and please give this video a like and subscribe so the algorithm tells you and the world when new science is ready to be learned.
Hi. I can't hear you, Pamela.
Hi.
Hi. There was like a second there where we were both like talking at each other and we were both muted and just exactly what you all have come to expect from CosmoQuest. Um,
So
it's not a
that
CosmoQuest stream unless we mute.
it's true. It's true. So welcome Raiders and Rocket Sage. Welcome.
Yes.
Uh,
Hi.
we are so glad to see you. I'm Dr. Pamela Gay. I go by Starstrider on the internet. This is Allie. Which internet handle do you like to share?
I on Twitter I'm Ali Star Stuff and I'm inane English everywhere else.
And
Um
uh, she is my producer who manages to, in all the right ways, make our show what it is. And I think our entire staff was cackling throughout that episode. And I know that when I recorded it, I was having the worst morning ever. It
she makes the best faces. Like it's a breeze to edit like because like honestly like your facial expressions are doing the work.
But like, I was having the kind of worst morning where I couldn't say falcon at one point. I don't know why. I just couldn't.
Oh my goodness. Yeah, she was like having a big words are hard morning and the rough video was rough.
And you can't tell. It was
I've
glorious.
I'm so glad. I'm like I'm getting good at that. So that's part of the fun for me is like every episode is an opportunity to like refine my editing skills.
And I just want to welcome all the Raiders and let you know what you have stumbled into. So CosmoQuest is a online community that produces all sorts of different ways for you to engage in learning and doing science. Escape Velocity Space News, which you just caught the end of, is one of our podcasts. We also have the 365 Days of Astronomy podcast, which is a community driven podcast with contributed audio from
Mhm.
hundreds of contributors over the
And if you
years.
come back tomorrow, you will get to meet a bunch of them because we're having a 15th anniversary
Celebration.
celebration.
And and then we have our Astronomy Cast podcast, which has been going since August of 2006. We just
Oh my
finished episode 730. And in addition to this, we do citizen science projects. We do a booth at the local museum. We do other public activities whenever we can. And we are able to do this, and we are able to address science topics like climate change, like wanting SpaceX to follow the federal rules and regulations, because individuals like you make it possible through your patronage at patreon.com/CosmoQuestX, through one-time donations at the link that is about to appear in the chat, and through the bits and subs we get here on Twitch. And we are so grateful that you have looked at the world and said folks like us deserve to keep doing what we're doing. Our goals during this hangoutathon are written beneath me. If we hit 5.4 thousand in the 2 days of the show, which really we could hit it tonight, we are just over $1,000 away from our initial goal. Um,
Yeah, we're like really close. And if we hit 7,000,
so
am I
five,
getting that right? Is that
so
number
it's
right?
7.5. It's $7,500. The newsletter comes back,
Yes. And
and
if we
then
hit our stretch goal of $10,000, I get a new production computer, and I'm very excited about that. I hope we hit our stretch goal. because then I'll be able to like make even more awesome videos,
Yeah.
and do more production stuff. I'm really excited about getting a new machine. My current editing machine it's a little close to end of lifing. Like
Yeah.
it's kind of at
Yeah.
its like any day now stage.
So if you can share out what we're doing, if you have extra to give, and if you can just stay and hang out and encourage raids from other raiders, all these things are
Yes.
supportive. We are currently in our 11 of streaming today.
Wow.
Yeah, we've had to bump the stream a couple of times. My software crashed at one point, which was rude. And
That's
YouTube decided it hated our guts at one point, which was rude. Um, but yeah, we've been here for 12 hours now.
just a couple of
11
hiccups.
hours.
I think we're doing pretty good.
Yeah.
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 And our next segment, I am going to play Minecraft for the very first time. I have never played Minecraft. Hex was lovely and walked me through how to get on the server
Oh,
because
good.
I literally had no idea um about like how to correctly launch different versions of Minecraft, but now I know that. So y'all can watch me in real time learn how to play Minecraft, and it's going to be very silly. And I appreciate Kitten, who manages the server, for letting me come hang out and learn how to play Minecraft. Because I apologize in advance if I break anything.
And
Um,
and this is actually something that is I went through just a few years ago. Back in 2020, October of 2020. Has it really been that long? Someone in
yeah.
chat, correct me if I'm off by a year. No, it was 2021. In October of 2021, when the pandemic still felt so dark and terrible, and we were all still living at home, um, one of our community members, Paranor 001, um, he was a Minecrafter, and we were all hanging out in Discord constantly because it was the pandemic.
Hmm.
And I was rebelling against playing games because that prevents me from doing science. And he was just like, no, there's education. And I mean, he didn't say it that way, not at all. There was a lot more badgering by a lot more people, and he was simply the driving badgerer. Um,
Hmm.
and so I'm being told it was 2020. I did have it right the first try. And
No, I remember it was 2020 because I was still living in Atlanta.
that's right.
And everyone was all y'all were also badgering me to
It's
get
true.
on Minecraft, and I'm like, I will never get anything done
And we understood
ever.
that.
I can't do that. And it has been 4.5 years, and y'all have finally worn me down. I'm gonna do it.
So Paranor got the idea that we should, as part of our hangoutathon that year, do something massive. And he got Kitten involved, he got me involved. And the idea was we should build a scale model of the entire goddamn solar system. And so we did during Hangoutathon. But Paranor wasn't with us. He died just a couple of weeks before the Hangoutathon. And so our Minecraft is dedicated to him, and you will find blue boxes scattered about all of our builds because he always referred to himself as a madman without a blue box, and we just hope he found his blue box. Um so yeah, getting you into Minecraft is
Mhm.
passing on the tradition because a lot of us, the way we dealt with our grief from him passing away was we just built. And the way we dealt with not being able to get out of our house during Hangoutathon was we just built. But there have always been people, Arnstra is one of them, Jillian is another, who are like, no, no, I'm going to watch, I'm going to enjoy watching, but no. Um, yeah. Veronica and I have built massive things in the nether at various points. I just started building buildings I missed in Europe. Yeah, these are the things we do. These are the things we do. Now, we are 10 minutes away. We are at the end of this segment. So one of our great sadnesses, this is the Escape Velocity Space News segment, is we are putting our heart and soul into this beautiful little show. And we apparently are really bad at search engine optimization. We're working on it. But if every single one of you right now could go to our YouTube page and subscribe and then watch
That would give
our
us a great
shows.
boost.
Yeah, just share out what we do. We are super proud of these, and yeah, we're just super proud of these. And we want more people to learn science.
It's always weird. Like I was up late last night finishing this episode, actually. And so it's always like, I don't know, it's fun to see people react to it, interact with it, and I'm glad that y'all love what we do.
This
It's
entire room
awesome.
was cackling at the chats, I just want to say. I know every Twitch streamer says that they have the absolute best chat. You are among the best chats, and to me, you are the best chat. You're pretty special. All of you are pretty special. So we have to reconfigure everything, which is part of why we do this at the end of the day, in order to do Minecraft, by which I mean I need to change the screen share and open up Minecraft. And anyone who's a CosmoQuest mod who wants to join in voice, there's a clearly marked voice channel. You are all welcome. I'm going to ask anyone who's in the room with me to not do it in the room with me.
Don't confuse her.
No. I'm going to throw over to our interstitials. Those of you who are here from Rocket Sage's stream and haven't seen these before, we have fart jokes animated. Please stay for the interstitials. All right.
Science fart jokes.
Science fart jokes. And don't lick the sun. We were asked, what would it taste like if you licked the sun? And the answer is probably chicken, but we don't know. Don't lick the science.
Yeah.
So, yeah, there's that. All right, I'm going to throw to interstitials, and we'll be back on the other side. Bye-bye, everyone.